Hello everyone, welcome back. Welcome to Q4 Week 7. This week we are going to be talking about Radian measures. It's going to be a short lesson where you have only one objective. This is your last week of new work for my class, as well as probably some of your other classes that you have on virtual learning. After you complete your Khan Academy and your classwork that's due on Friday, you have nothing new for my class. Next week will be focused completely on catching up on late work, missing assignments, that sort of thing. So yeah, announcements. I guess I already went through the first one. So last week of new work, you have one more classwork and one more homework due. The homework is just one objective. Next week, we're focusing on helping students who are failing for the most part, getting those assignments turned in if they're missing. I'm going to turn on a light. Give me one sec. And then lastly, if you finish your work and you would still like to raise your grade, remember that the Khan Academy extra credit, that's always a thing, even though we're doing virtual learning this quarter. You can do the Algebra 2 mission on Khan Academy and raise that mastery percentage. Every 5% that you get in mastery of new content on Khan Academy is a 1% grade boost for the quarter. If you do a lot and you get up to 20% mastery over the course of a quarter, you can get a 5% grade boost. And those grades will be put in the last thing at the end of next week, May 29th at the earliest. Today's objective, we just have one. Khan Academy will convert radians to degrees and degrees to radians. So first of all, what are radians? All right. Radians are just an alternate measure for angles. You can measure angles in degrees, right? One full rotation of a circle is 360 degrees. A half of a circle is 180 degrees. We can also express that in radians. So 2 pi radians is a full rotation of a circle. Split that in half, 1 pi radian is 180 degrees. And then split it in half again, 90 degrees is the same thing as pi over 2 radians. This would be the start of a new unit, but because we've run out of time in the year, we aren't going to be talking about the rest of the trigonometry unit, unfortunately, just this intro lesson. But radians, why are they important? It's because they're used in upper level math. Like once you reach pre-calculus, calculus, that sort of thing, radians are so much more valuable than degrees in a lot of contexts. So you want to know how to use them and be comfortable with them. But please realize that radians and degrees are just like, I don't know, feet and yards or miles and kilometers. They are 2 different units to measure the same thing, angles. Last note is that radians can also be expressed as decimals. You will usually see radians expressed in terms of pi, right? This angle is pi over 4 radians or 5 pi over 6 radians. But you can also change that expression with pi to a decimal. For instance, 2 pi radians, a full rotation of a circle, 360 degrees. You can also express that as a decimal. Type 2 times pi into your calculator and you'll get 6.2831. 6.2831 radians is the same thing as 2 pi radians, is the same thing as 360 degrees. But remember, anytime that you have the pi symbol, it's better to actually write that pi symbol because that fully expresses the irrational number. With a decimal, you have to cut off the decimal somewhere and it's not as accurate as it could be. Converting between degrees and radians is what we are going to be doing today. And really it's just a simple little conversion. Because there are pi radians in 180 degrees, 180 degrees is the same as 1 pi radians. That's going to be your conversion factor that you're multiplying by in these problems. If you wanted to convert degrees to radians, you start with degrees and you want to end up with radians, you multiply your degrees by pi over 180. And then simplify the fraction. To convert radians to degrees, you just have to multiply by the reciprocal of that, 180 over pi. Simplify the fraction, the pi's will cancel out, and you will have a degree number. And as I said in the previous slide, leave the pi symbol in your answer unless the question asks you for a decimal approximation. because leaving the pi symbol in fully represents that irrational number pi. It's best to leave the symbol in. Now we're ready for examples, and we're going to be going over 4 examples. 2 where you're doing decimals to, 2 where you're doing degrees to radians, and 2 where you're doing radians to degrees. This is going to match pretty much what you have to do on the Khan Academy. Alright, so our first problem, we are asked to convert 2 pi over 9 radians to degrees. So if we return to our notes, we know that we need to multiply this by 180 over pi to change this to degrees. The only thing that you could struggle with in these problems is simplifying the fractions. But honestly, if you're fine with that, this is going to be a very, very easy lesson for you. So the first thing that you do when you're converting radians to degrees is cancel out those pi's. Pi on top and pi on bottom, you can cancel those out. You're going to get a degree number without pi, which is what we want. Next, if there's anything on top and bottom that are divisible by a common factor, you should simplify that. I see 9 on the bottom and 180 on top. And I know that both of these numbers are divisible by 9. So I'm going to divide the 9 by 9, and I'm going to divide the 180 by 9. Let me bring this down to a new step below. 2 over 9 divided by 9 is 1, so 2 over 1 times, we did 180 divided by 9, that's going to be 20, over, we canceled out the pi, so we are just going to write 1. So now we have 2 times 20. 2 over 1 times 20 over 1 is 40 over 1, which is 40 degrees. So 2 pi over 9 radians is the same thing as 40 degrees. Example 2 asks you to do a similar thing, but in the opposite direction. So now you start with degrees and you have to go to radians. 60 degrees as a radian measure, we are going to take 60 degrees and we are going to multiply by the reciprocal of what we did before. Instead of 180 over pi, we are now doing pi over 180. 60, if you want to make that 60 over 1, because you're multiplying by a fraction, you can do that. It's very important that you simplify the fraction either before or after you multiply. I like to do it before. It's just easier. Simplifying those smaller numbers before you multiply them together. So simplifying this fraction, I see 60 and 180 as 2 numbers with common factors, one of them being on top and one of them being on bottom. 60 I know is divisible by 60. And I know 180, you can divide it by 60 as well. 60 divided by 60 is 1. 180 divided by 60 is 3. So now we have 1 times pi over 3, which is just pi over 3. Oops. Pi over 3 radians is the same thing as 60 degrees. So pi over 3 is our final answer. If you wanted a decimal approximation of this, not saying that you would, all right, but you could plug in pi divided by 3 in your calculator, and it gives you 1.0472 radians. I don't think Khan Academy will ask you to do that, but I may ask you to do it once on the classwork. So a couple more examples for you, just in case you need to see more. We're going to go through 2 more, one of them radians to degrees like this problem, and then the next will be another degrees to radians. Here we have convert 11 pi over 6 radians to degrees. I'm going to take that 11 pi over 6, and I'm going to multiply it by 180 over pi. If you ever mix up whether it should be pi over 180 or 180 over pi, remember that from radians to degrees, the pi's should cancel out. So one of them should be on top and one of them should be on bottom, right? So the pi's cancel out. What else can we simplify? Well, 6 and 180 are both divisible by 6. So I'm going to do that. Bringing it down to the next step as I simplify, we've got 11 on top still, divided by 6 is 1, times 180 divided by 6 is 20. And finally, pi was canceled, so we just have 1. So now we have 11 times 20. 11 over 1 times 20 over 1, which is 220 degrees. Our final answer, this is the same thing as 11 pi over 6 radians. And one more. Let's say that we have 225 degrees and we're trying to convert this to radians. We're going to take 225 and we're going to multiply it by pi over 180. This is equal to 225 pi over 180, but you got to make sure that you simplify, right? What number is a factor of both 225 and 180? Well, I see 225 and 180, they end in a 5 and a 0, so I know it's divisible by 5. So I'm going to quick do that in my calculator. I'm going to divide both 225 by 5 and 180 by 5 to simplify this a bit. 225 divided by 5 is 45. So 45 pi over 180 divided by 5 is 36. Cool. Can we simplify this more? 45 and 36, are there any common factors for those two numbers? And the answer is yes, right? What number goes into both 45 and 36? The highest number I can think of, the greatest common factor, is 9. So simplifying this once more, 45 divided by 9 is 5. So we have 5 pi over 36 divided by 9 is 4. So we have 5 pi over 4 radians. That's my final answer. If you have any struggles and want to see additional examples, reach out to me on video chat either at 10:15, 11:45, or 1:45 Monday through Thursday of this week. Get the stuff done early, and this is the last thing that you have to do for virtual learning. I hope you all have a good rest of your week, and I'll talk to you later. Bye.